titration lab is your second formal lab report, and the good news is it's also your last. But I'm going to take some time now to give you some helpful hints about how to write this up so you can get a good grade. My suggestion is, as I'm pointing things out and telling you some things, my suggestion is that you write this down on your own lab sheet. You can go back and watch this video multiple times if you want, but if you're taking good notes, that won't be necessary, and you can get a good grade on the lab. So let's get started. On the title page, make sure that you use a scientific title. Titration lab is not a scientific title. It should tell the reader exactly what your experiment is about in a few words, very few words. It should say something about, finding the unknown concentration should be there, using titration, something along those lines. You need to make sure that you tell the scientists exactly what it's about without being too long. I'm going to give you some no-no examples from the density lab that you did last quarter. It definitely should not say density lab, so if you said that, that was not scientific. Something else, fun with pennies. So that's not a good example. So your scientific title should not be one that's like fun with exclamation points, but instead it should tell the scientists exactly what you're doing in this experiment without using the word lab. When it says date, that should be the date we did the lab. So look back at your unit guide, see the date we actually did the lab in class. Okay, purpose, I feel like you guys are good there. Just remember, clear, concise, meaningful. Should not be extremely long. Materials, it's something here. Make sure that you're including sizes of the glassware. So instead of saying Erlenmeyer flask, tell me exactly what size of Erlenmeyer flask you used. And then also don't forget your safety equipment. Make sure you list that as well. And your chemicals, okay? Procedure, put it in your own words, okay? What did you do in the lab? Make sure it's repeatable, make sure it's clear, but also as far as grammar, commands are good. Definitely do not use any pronouns. So we did this, we did that, no. Okay, data and observations. Now, your last lab report did have a section where you were supposed to write the observations. On this, I'm asking that you don't write out the observations. Instead, put them in your table, just like it is on your normal lab sheet. Put them in your table, and your observations should be talking about, did you over-titrate? Did you, what was the color at the end of the solution? How many drops did you have to add in order to get to? At the end, did you over-titrate by 1 drop or by half a drop? Whatever. And then make sure that you're checking that there are correct number of sig figs. Make sure that your data table is titled. Okay, calculations. With this, you have to calculate the same way that we calculated in class. The way I showed you how to do titration calculations, that's how I need you to do them here. If you are finding another way that you think is easier, you're probably not going to get any credit for doing your calculations because you need to do it the same way I did. Remember, I had 4 steps. Let's see. Write the balanced equation. Calculate number of moles of known. Use your mole to mole ratio to find moles of unknown. Calculate molarity of unknown. Those are your 4 steps, and that's what I want to see in your work. This should not be on your lab sheet. Your calculation should not be on your lab sheet. I never want to see that lab sheet again. Remember, you're retyping this up. You're typing this up using the computer. You're printing it out. There should not be any of that lab sheet. I don't want to see it again. The calculation should not be at the back of the lab sheet stapled. You should leave space in your actual write-up. Either type the calculations in or handwrite them neatly in pen, but it should be incorporated in your lab. Notice there are points for that. Correct format, pen or type, incorporated into the lab report, not separate or lab sheet at end. That's 5 points. So it should not be tacked on to the end. Okay, the conclusion is where you're talking about your results. What are your results? Your results are the molarity of your unknown. So you should be listing your molarities there. You should also be listing so you also should be calculating percent error for each, because I'll give you the actual concentration. Your sub will actually give you the actual concentration in class. You need to calculate a percent error, and your conclusion should discuss that. Look here. Discussion includes a connection between the student's measured results and expected results. How do we compare measured to expected? That's a percent error. And when it says discussion, you shouldn't just say this is the percent error. You should discuss it. Are your results accurate? Are your results precise? So list 3 polarities, list 3% errors, and actually discuss the accuracy and precision of your results. In doing that, you should make it very clear that you understand the purpose and that you're answering the purpose. So go back to the purpose section at the top and make sure that your conclusion is actually answering what you were trying to accomplish. Okay, let's move down to discussion of theory. We've now written quite a few discussions of theory, so I'm hoping that you're feeling pretty good about them now. Remember, it is not just sentence after sentence answering my questions. So I'm giving you, should include, but not limited to, but not limited to. So make sure that you are including more than you think you should, or more than what's listed here. You're not just defining these words. So it should not feel choppy where you talk about titration, then reaction type, then indicator, then endpoint, then equivalence point. You're not just defining those words. It should be an overall paragraph discussing the content, the theory of this lab. What is a titration? What is it used for? How does it work? And you are relating it back to our specific titration, but this section should feel more like a textbook because you're talking about the theory rather than the experiment itself. But do relate it back to the exact acid and base we used and the indicators we used, things like that. Okay, there's the infamous sources of error. I'm going to give you some no-nos, okay? These are ones that you should not include. Don't mindlessly blame the equipment. Do not say, our burette was not accurate enough. No, we communicate how accurate the burette was using significant figures. So if you go to the hundredths, that tells the scientist how accurate or precise the burette was. So there's no point in you talking about that in the conclusion, in the source of error, so please do not. You should not talk about contaminants. So don't say this was contaminated, this was contaminated, the standard was contaminated. No, it should be, if you really feel like something's been contaminated, you need to be as specific as possible. And honestly, if you are aware of a contamination, we really should have redone the lab. It's not a really good one to talk about. Inaccurate standard. Guess what? Your science teachers here made the standard and they did a really good job. Don't blame the science teachers who made the standard. The other thing is we have that one has sig figs, significant figures. So it should be the first few numbers are accurate, the last number is estimated. That's communicated in the concentration value that we give you for that. Don't blame the standard. I don't want to see the word temperature. No, temperature in this room temperature is not going to affect the results. Unless in the middle of our lab the temperature increased by about 200 degrees in the midst of us doing the lab, then yeah, you're going to end up with some results because you know, you're going to end up with more water evaporation at that point, but I'd be very concerned for our health if the room increased by 200 degrees while we were working. So do not mention temperature. The effect of maybe 0.1 degree change while you're doing the lab is nothing. So don't mention the word temperature. Don't mention the word dust. And then human error. We messed up. We calculated incorrectly. First of all, you shouldn't be using we's. And secondly, those are not good. If you made a mistake, you should go back and do the lab again. Don't talk about it in your sources of error. Any mistake you make, that's a mistake. That's not a source of error. So the other thing, once you figure out a source of error, remember we are going to turn this lab in on turnitin.com. So you are going to be checked for cheating. When you find a good source of error, keep it to yourself. Because if you're sharing your 3 sources of error with someone else in the class, you've got a much greater chance of that person, or not even just this class, but in the school, you've got a much greater chance of getting matched with them. So once you find a good source of error, keep it to yourself. Keep it to yourself so you don't get a match on turnitin.com. Here comes my hint. I told you a bunch of no-nos, but here comes my one hint. Check out that Carolina biological video that I showed you before we did the lab. It does give you some hints about some potential sources of error. It does not say, this is a source of error, ... No, but it does. If you listen closely, if you watch the entire video again, you are going to see quite a few. It probably mentions like 3 or 4 potential sources of error. But you've got to listen closely for it. Okay, so watch that video and that might help you. And I will tell you, the density lab, I think is pretty difficult to come up with some good sources of error. This lab, the titration lab, has tons, and you need to come up with 3. The last thing I want to tell you, this part's just as important, if not more important, than the original source of error. I'm going to tell you, each source of error is worth 3 points. 1 point for identifying a good source of error. 2 points for explaining how it impacts your results. So ultimately we measured a molarity. So you need to tell me if it caused the molarity to increase or decrease. And what did we measure? We measured the molarity of, we measured the volume of the acid. We measured a volume of the base. Is your source of error affecting the volume of the acid, or is it affecting the volume of the base? And if it does it make it appear to be too big or too small? And if so, how would that impact your ultimate molarity example? Don't just blindly say it would increase. Go through your calculations and see if this number's higher, how does that affect the molarity? So make sure that you're talking about that. So I'm going to be looking for, this is the source of error, ... It caused the molarity to appear larger than it should because it caused this volume to appear larger or smaller than it should have. So you're actually explaining how it would ultimately affect your results. 1 point for a correct source of error, 2 points for the explanation. So if you're really good at finding sources of error but you can't explain them, you're going to be getting 3 or 4 points out of 10. So make sure you're explaining your sources of error. Okay, let's go to the next one. Your lab sheet does have some questions to answer, and I want you to answer them. Do not turn in your lab sheet though. Remember, I don't want to see that again. Instead, type them up into your lab in this order, so it should go right after the sources of error. Type them up and answer them up typed. And I do want them in complete sentences, except if the calculation ones, of course, don't have to be in complete sentences. For the calculation problems, yet again, I do not want those calculations at the end of your lab. They need to be in the midst of your lab, in the question section, next to the 2 questions that are calculations. Make sure you're actually calculating it, again, the way we did in class, not maybe another way you saw how to do it, maybe with your tutor or something like that. No, you need to do it the way we saw it in class. Otherwise, you will not be getting credit for them. And then, yeah, make sure it's complete sentences. Make sure your work is pen or typed. If you want to write it in pen, leave some space, print it out, write it nicely in pen. I don't want to see any pencil anywhere. Works cited. You need to have at least 1 source. That is in addition to your lab sheet. So you should cite your lab sheet, and then you should have 1 additional at least. Okay? So if you have, that's 2 total, bare minimum, 2 total. Okay? So I should put a 2 here. Your lab sheet and 1 more. Here's what I'm going to be grading on it. Is it alphabetical? And did you indent the second line and beyond? So if there's 3 or 4 lines, they all should be indented. That's all I'm looking for when I'm looking for what I'm grading with MLA. As far as how to cite your lab sheet, I personally just look up a way to do it in MLA style formatting. I don't tend to take as many points off for like you didn't put a comma here, or you should have started with a name. I don't usually look at that as closely. As long as it's alphabetical and you indent the second line, that's really what I'm looking for. 2 sources. One last thing, if you do use a program that does it for you, cool, you're using your resources, that's awesome. Make sure you get rid of the highlighting. If it's in a different font as the rest of your paper, change the font. Some of you are like, I don't know how to do that. Retype it then. Do something to make it look like it fits in your paper, because it's really cool to use those programs, but if I can see that you used it, it's not very professional. So make sure it matches with the rest of your paper. Okay, so if you follow these are going to be freebie points, but if you don't follow them, you've just lost some freebie points. Past tense verbs, no pronouns. I's and we's, nope. Use, nope. Double space, typed. Subscripts, let me give you a hint of where you've, maybe you lose this point. This is not a subscript problem, but I do not want to see that. We're using HCl, but you need to know what HCl is. That is not HCl. It's hydrogen with chlorine. So do not put a capital L there. When I read that on your labs, I'm like, have you learned anything this year? Do not have a capital L. It's chlorine, hydrochloric acid. Chlorine is capital C, lowercase l, so please watch that. And grammar and spelling. Outcome scientific, and then what do you need to turn it in on turnitin.com? Turnitin is due at 11:59 the night that your lab is due. So you turn your lab in class. By 11:59 that night is when your Turnitin submission is due. Let me tell you what you need, and I would suggest you write this down. These 3 sections, those are our Turnitin. So I would suggest you write Turnitin next to those 3. Okay, your nope, not calculations. Oop, I got this wrong. These 3, so not that. These 3. So not calculations, we're doing conclusion, discussion of theory, and sources of error. Let me say that one more time since I messed it up. Conclusion, discussion of theory, sources of error, those 3. Remember on our density lab, we did conclusion and sources of error. I'm just adding the discussion of theory on this lab. Okay, so those 3, conclusion, discussion of theory, sources of error. This is what you're going to do. The day that it is due, you're going to have it printed out, the entire thing, including these 3 sections. You're going to have printed out, and you're going to have this rubric stapled to the back. The rubric can have stuff written all over it if you want. It tells me that you were listening, that you were thinking about it. I don't care if stuff's written all over it. But you turn in your rubric, stapled to the back of your lab. Remember, even your Turnitin submissions, even your Turnitin sections are also there. Print out the entire thing. Staple the rubric to the back. You are going to turn that in the day it's due. Then you will have by 11:59 p.m. that night to additionally submit just these 3 sections on Turnitin.com. I do not, we give you that 20% buffer down here because we are giving you the benefit of the doubt. But if you're above 20%, unfortunately, there's proof that you have plagiarized. So make sure that you are being honest here. Let me tell you some things that are not honest. Sharing sources of error with your friends. Borrowing a lab to help you because you're stuck. It will catch you even if you try to write it in your own words. If you take out a few of words and replace it with your own, it's going to catch you. I would suggest if a friend comes up to you and says, here, borrow my lab, here, just look at it, it might help you. You say no. Why? Because that's going to give you a 0%, and that's going to give that friend a 0%. So don't do it. Most people who plagiarize don't intend to plagiarize. Taking something from a friend or online and changing a few words to try to make it your own is cheating, okay? If a friend says, I'm really struggling, can you help me? You can say, yes, I will help you. Don't have your lab out. Put your lab away and give them some helpful advice, just like I'm doing now. I'm giving you some helpful advice. But do not give them your lab report, because guess what? They might end up purposefully or accidentally copying it, and now you're in trouble just like they are. Do not share your lab reports with other people. Keep them to yourself. And again, once you find a good source of error, keep it to yourself. Do not share it with others, because you don't want to get dinged on Turnitin on accident. So there you go. So feel free to watch this video as much as you need to. You've got about a week plus a few days to do this lab. I would suggest you get started on it as soon as you can, because you know it's going to take a lot of time. But good luck. I wish you all the best.